Alright, let's look at the homework 9.2, problem number 10. Alright, so this is a cooling of a coffee problem. Alright, so let's look at that. Alright, so one knowledge you need to have is Newton's law of cooling, and it states this. The rate of cooling of an object is proportional to the temperature difference between the object and its surrounding. Alright, so if you write the differential equation, so rate of cooling, so it's going to be d, if it's a temperature, dt. In this case, actually, they are using y. So dy over dt, so y is the temperature. And this is proportional to the temperature difference. So y is the temperature of the coffee, and the surrounding is the room temperature, which is 18. So you have negative 18. Alright, so according to the Newton's law of cooling, this is the differential equation. Alright, then it gives us a more clue here. It says that it cools at the rate of 1 degree Celsius per minute when the temperature is 98 degrees Celsius. Right? So which means that it's going to be rate of cooling, so it's going to be negative 1 and a k times when y is 68. So we have negative 18. So this is going to be 50 times k. So we can simply divide through by 50 to get the k value. So k is going to be negative 1 over 50. Alright, so we have a differential equation, so it's going to be negative 1 over 50 times y minus 18. Alright, so let's type it in. Alright, so differential equation is negative 1 over 50 and times quantity y minus 18. Alright, let's just go ahead and check the answer first. Alright, oops, I put 8 instead of 18, so 18. So check again. Alright, we got part A correctly. Alright, so let's look at the part B. Alright, sketch the direction field and use it to sketch the solution curve for the initial value problem. Alright, so which one is reasonable? Alright, so let's see, when y equals 18, the slope should be 0. So if you look at the 18, like first picture, slope doesn't look like 0. Alright, and here 18, it looks promising here. Alright, so second picture looks okay. And how about the third one? And the third one looks okay too. And so it looks like here, 18, it's 0. Alright, so this one, not so much. So it's going to be the second picture or the third picture. Alright, so which one is more, alright, so only difference is the starting temperature. Alright, so it looks like here, starting temperature here is going to be, let's see, that's about 90. Alright, so what was the, oops, originally it's a 90 degree, but here starting temperature is actually less than 80, so this shouldn't be it. So the picture we're looking at is this one. Alright, let's check the answer. Alright, so we got the correct picture. Alright, then what is the limiting value of the temperature? So as the T approaches infinity, and you can see that this is approaching the degree 18, which is the room temperature. And you can see that if you leave a coffee in a room, and the coffee temperature of the coffee is going to cool down to eventually the same as the temperature of the room. So that will be 18. Alright, so let's check that again. Alright, we got this one correctly. Alright, part C, use Euler's method to with the step size h equals 2 to estimate the temperature of the coffee after 10 minutes. Alright, so let's bring out the GeoGebra. Alright, so I'm gonna just, we don't need the graphics, I'm gonna just close that. And I'm gonna open up the spreadsheet. Alright, so initially, so I'm gonna use T is gonna be 0. And then initial temperature is 90 degrees, so we'll put 90 degrees there. Alright, then what we're gonna do is step size is 2, so I'm gonna type H equals 2. And also differential equations, so I'm going to type in f of x comma y, and this was negative 1 over 50 times y minus 18, right? 18. Alright, so we got that. Alright, then we're going to just apply Euler's method. Alright, so this one, I'm going to put the formula, so it's going to be equal to, oh, sorry, I messed that up, here, go down here. So it's going to be simply take A1 and add H to it. Alright, so of course 2. So I'm gonna copy this guy and paste it down here. So, oops. And, alright, so I'm going to, let's see. Sorry, it's not working for me. Alright, so I'm going to copy this and then bring it down to here. Alright, so then right click and paste. Alright, so here, what I'm going to do is take the B1 value, so is equal to, take the B1 value, and then we're going to have H times capital F of A1 comma B1. Have that, and then I'm going to just copy this and then paste it down to here. Right? Alright, so you can see that when, let's see, T is equal 10 minutes later, the temperature is going to cool down to 76.71, and what's the precision? 2 decimal places, so that's exactly what they want. So 76.71 is the temperature. Alright, so let's check that, submit for testing. Alright, it came back and looks like we got this one correctly. Alright, so easiest way to apply Euler's method is use the spreadsheet. And you can see that when the time is equal to 10, the temperature is about 76.71. Alright, that's it. I hope that this was clear.